We're going to use systems of equations and matrices to solve problems in this KORNCAST. We're going to use before mentioned topics to answer the following question. So please take a moment and write this question down. As you read through these questions, the first thing you want to do is ask yourself, what is this question asking me to find? For example, how many of each type of ticket were sold? Well, in order to answer this question, we need to ask ourselves, well, what are the types of tickets? Well, the first one that we came across are regular admission tickets. The next type of ticket would be our children's ticket. And then the last one would be our senior ticket. Once we've decided which are our types of tickets, we need to assign a variable to them. We could use R, C, and S, but I'm going to go ahead and let my regular ticket be X. I'm going to let my child ticket be Y, and I'm going to let my senior ticket be Z. And I just think we're more familiar with the X, Y, and Z as opposed to the other variables. But as long as you pick variables that you like, that's okay. Once we've defined our variables, now it's time to decipher the information. First thing I see is that we have cost for tickets. And I also notice that we have our revenue for the problem. The next thing I notice is that we have our total tickets sold. And the last thing I notice is that we have a situation where we have 100 more regular tickets sold than children's and seniors combined. So since I have three scenarios here, I need to come up with three equations. One for tickets, one for revenue, and the last one I would say for other. So let's take care of the tickets first. Since we know we sold 500 tickets, that means we sold a combination of regular tickets, children tickets, and senior tickets. So the equation for that is going to be X plus Y plus Z is equal to 500. And that's because we don't know exactly how many of each type of ticket we sold, but we know they total 500. The next one is our revenue, and that's going to deal with money because when we sell a regular ticket, we get $4. So our revenue equation is going to be 4 times X because we know that for every regular ticket we sell, we're going to gain $4, so we're going to multiply. We know we're going to get 2.5 Y. And again, because we know for every child ticket we sell, we're going to make $2.50. And we're going to get 3Z. And again, for every senior ticket we sell, we're going to gain $3. To get our total revenue, we're going to go ahead and add those values up. And that revenue is going to be $1,740. Now, the other equation is a little bit challenging because we have to decipher what this information is telling us. Now, as we read through this, we're saying 100 more regular tickets. And so we're probably thinking 100 plus X. But that's an incorrect assumption on that one. So what I like to do is a situation that I call role-playing. And what I mean by role-playing here is let's pretend we have a situation. We have our regular tickets. And because we're doing children and seniors combined, we're going to do children and seniors. Now what I mean by role-playing here is pick a number. Let's say we sold 26 children and senior tickets combined. Now, if I read carefully through this, it says if 100 more regular tickets were sold than children's and seniors. Well, in order for this to satisfy this condition right here, the regular tickets would have to be 126. Because I know that I need to add 100 to my 26 to make this happen. So when I first thought that I had to add 100 to my regular, what actually ended up happening is I have to add 100 to my child and senior tickets to equal my regular tickets. So please take a second and look at the role-playing scenario and how it helped us come up with the correct equation for this. So now my other equation, since my regular represents my x, I know I'm going to get x is equal to child plus senior, so y plus z, and then I'm going to add my 100 to that. So that's my third equation. Now what you notice is now that you have three equations and three unknowns, we now have a system of equations that we can solve. Now, before we use our matrices to solve this particular system, we have to make sure everything is lined up. And what I mean by that is that we need to have x's plus our y's plus our z's is equal to our numbers. So if I look at this first equation, that condition for using matrices is satisfied. I know that x plus y plus z equals 500 is lined up the way I need it to be. So x plus y plus z is equal to 500. And if I look at my next equation, 4x plus 2.5y plus 3z is equal to 1740, that is also lined up correctly because I have my y's, or my x's, my y's, and my z's where they're supposed to be. So 4x plus 2.5y plus 3z is equal to 1740. And again, my y's plus, or excuse me, my x's plus my y's plus my z's are equal to my numbers is correct. Now, as I look at my last equation, I notice they are not lined up correctly. I have x equals, and that is not lined up the way they're supposed to be for matrices. So what I have to do to this is I have to move my y to the other side of the equal sign. So I need to subtract a y from both sides. And I also have to move my z over there. So I'm going to need to subtract a z from both sides. And so what I get on my left-hand side is x minus y minus z. So now I'm going to line it up correctly. So x minus y minus z is equal to, well, the y's cancel, the z's cancel, 100. So with some solving equation knowledge right here, I was able to put this equation in a way that works with matrices. So please make sure that we line our matrices up correctly. So x's, y's, z's are equal to our numbers. So once I've realigned my system of equations, I now can use matrices to solve the system. So the first thing that I'm going to do is I'm going to matricize the left part of my system as well as the right side. When I do that, I'm going to get my coefficient matrix. 1, 1, 1, 4, 2.5, 3, 1, negative 1, negative 1. And that 3 by 3 matrix is going to be multiplied to my unknown matrix, x, y, z. And that product is going to equal my 3 by 1 matrix, 500, 1740, and 100. And if you recall, to solve this, we need to multiply both sides by the inverse. So that's going to leave me with my unknown matrix, x, y, z, is equal to my coefficient matrix, that I have to take the inverse of, and then I'm going to multiply that inverse to my 3x1 matrix. Once I've got my equation set up, I'm going to now use my graphing technology to help me out with that. So I'm going to enter my coefficient matrix into my calculator. Then I'm going to have the calculator perform the inverse on that. And then I'm going to multiply that by my 3x1 matrix. And the resulting matrix will be 300, 120, and 80. So my answer for this particular system, I'm going to get my unknown matrix, x, y, z, is equal to 300, 120, and 80. Now I have my matrix equality scenario here. I know that x is equal to 300. Well, if we recall, x is really equal to our regular tickets. So that means that we sold 300 regular admission tickets. Again, because of matrix equality, my y is equal to 120. So y was our children tickets. So we sold 120 child tickets. And lastly, again, because matrix equality, z is equal to 80, and that's our senior tickets. So we sold 80 senior tickets. Okay, so now that we've answered the question, let's answer it correctly. And because the problem asks us a question, we're going to answer it. And in order to do this problem correctly, we're going to answer it using a complete sentence. So our answer is going to be as follows. 300 regular admission, 120 children, and 80 senior tickets were sold at the basketball game. And again, that answers how many of each type of ticket were sold. You made it.